Welcome to lesson 7.2, day 2. Today we're going to be writing polynomial functions. So we're going to go in reverse of the previous lesson in which you were given the polynomial function or equation and you factored it to find the zeros. To write polynomial functions, we're going to go in reverse. We're going to start with those zeros and some other information and write the function from those zeros. In this example, we're going to look at how to write a polynomial function from a graph. So given this graph here, we're going to write the actual function that goes with it. The first step is to find the zeros, the x-intercepts from the graph. We're going to look for any multiplicity. So let's talk about what multiplicity. Multiplicity are any turning points, also called like bounce points. So here's an example that it kind of bounces, or there's a turning point as a zero, as an x-intercept, meaning there's actually a double root right there. We're going to use those zeros then to write in factored form. And then we're going to use the y-intercept, or we could actually use any point on the curve, but the y-intercept's easy to use and easy to find the leading coefficient. So let's take a look at how that happens. So I'm going to zoom in here. So first let's figure out what our zeros are. In this case we have our zeros. I can see one right here at -6. And I have one there at 5. But there's a multiplicity, meaning there's actually 2 there at 5. So we have our zeros. Then we're going to write our function. I'm going to call it f of x. What we don't know is this leading coefficient, so I'm going to just put a letter A there for that coefficient, and we're going to write this in factored form since I know my zeros. So this would be x plus 6, x minus 5, and I'm going to put an exponent there to let me know that I have 2 of those. Now we need to find this coefficient out front, and one of the ways we can do that is to use a point from the graph. So here is a point that we can use. We can use the point, our y-intercept, which is 0, -25. And we're going to substitute in, anywhere we see an x, we're going to substitute in 0, and a -25, we're going to substitute in for y. Or in this case, I've written it as f of x. So let me move the screen down here. And let's make those substitutions. So the -25 is going to go in for the y value, or f of x. We still have this a. And then I'm going to substitute in 0 for every x. We're going to simplify. So I still have the -25. I still have the a. On the right side, I have 6 times -5, right? 0 minus 5 is -5, squared is a +25. So let me keep simplifying here. -25 equals a. 6 times 25 is 150. So I'm going to divide both sides by 150. Let's move my screen down a little bit more. And we can simplify that fraction to be -1/6, which means our a is equal to -1/6. So let's write out the entire function now. The function is f of x equals -1/6, parenthesis, x plus 6, x minus 5 to the second power. I'm going to zoom out so we can see the graph here. And let's think back to Module 5 where we talked about sketching the graph of these. The leading coefficient is a negative number. And if we were to multiply this out, our leading term is going to be a degree x to the third, because we have x times x to the second. So let me x to the third. So this is a cubic So we know the end behavior being an odd degree, the ends are going to be going in opposite direction. And the fact that this is a negative coefficient, we do know that the left one end behavior will be going to positive infinity and the other to negative infinity. So just a way to check your function and to verify that your function does match the graph. Sometimes when you're asked to write the equation, rather than a graph, you're given some information, and from that you can write the equation. In this problem, you're told it's a cubic function, and here are the zeros, so you're given the zeros. And the y-intercept is -6. And we're asked to write the equation of the cubic function in standard form. So let's start with f of x equals a, and here are zeros, so I can go ahead and write that in factored form. Okay. Now our y-intercept is f of x is -6. So what we have to remember about our y-intercept is that the x-coordinate is always 0, and the y value is the output, which is -6. So just like in the last example, we're going to substitute in 0 for x and -6 for y, keeping in mind that f of x is y. So I'm going to move my screen down. And at this point, I'm going to actually have you stop the video and go ahead and make those substitutions and record on the quiz question what value you get for A. Alright, when I worked it out, I got a value of that leading coefficient to be -3. So let's keep going and write out our function. I'm going to move my screen down. So I have f of x equals -3 parenthesis x plus 1 parenthesis x minus 1 parenthesis x minus 2. Now that is in what we call factored form, but the instructions say to write it in standard form. That means we're going to have to multiply this out. And what I might do is start by distributing that -3. There's different ways. You can multiply this out. You can multiply it and distribute the -3 here, and then multiply these two binomials together. A variety of possibilities. If I do it the way I just mentioned, I'm going to end up with these two polynomials. That gives me -3x plus 2. And then I just keep multiplying it out until it's in standard form. And I've jumped ahead and worked all that out for you, and we have our final function in standard form. Okay, last example is writing a polynomial function from a table. The instructions for this one say the function is a quartic function, meaning x to the 4th power, and a limited table of values is provided below. Write the equation of the quartic polynomial in standard form. So we're given a table, and just like before, we need some information. We need to find the zeros, and also the y-intercept would be helpful, but we could use any points. So looking at the table, okay, we need to find some zeros, and that's when the function equals 0. So here's 1. Here's another one, here's one, and there's one right there. So there are our zeros. Now if you look carefully, you'll also find your y-intercept right there, because the x is equal to 0. So we can go ahead and set this one up. F of x equals some number a, x plus 3, x minus 1. I'm running out of room, so I'm just going to come down here and write this, x minus 3 and x minus 4. And we're going to use then our y-intercept of 0, comma, negative 36. So for every x, we're going to substitute in 0 for y. And again, keep in mind that f of x is y. We're going to substitute in 36 and solve for a. And again, I'm going to leave that up to you to finish this problem. Here is the final answer. A turned out to equal 1, and there's our final function. In case you're wondering, it does not matter which order these factors are written in.